Good day, I am Mark Daniel. Together with my groupmates Bob, Dylan, and Tiffany, we will present our final project titled Design and Verification of an RFID-based Attendance and Access Control Digital Controller using Verilog and VHDL. This diagram shows the overall flow of our RFID-based attendance and access control system. First, the RFID input or scan tag code is received by the system. That input is then sent to the authentication comparator, which checks whether the RFID matches one of the stored authorized IDs. If the RFID is valid, the system generates three outputs: access granted, attendance mark, and entry pass timer, comma. The access granted output allows the door or gate to open, while the attendance mark confirms that the user's entry has been recorded. At the same time, the entry pass timer keeps the entry pass active for a short duration before it turns off automatically. If the RFID does not match an authorized ID, the system will not activate these outputs, comma. This flow matches the project's methodology and functional description, where a valid RFID sets the access, attendance, and entry pass signals high, while an invalid RFID keeps them low. This diagram shows the RFID controller module of our system. On the left side are the inputs, which include the RFID data, clock signal, entry request, and reset. The RFID input contains the tag information that will be checked by the system. The clock is used to synchronize all operations, while the reset initializes the system. The entry request signal indicates when a user is attempting to access the system. On the right side are the outputs, which include access granted, attendance mark, and entry pass. If the RFID is valid, the system activates these outputs to allow access and record attendance. This waveform shows the initial behavior of the RFID controller when different RFID inputs are applied. At the beginning, the system is in a stable state with reset inactive, and the clock running continuously. When an invalid RFID input such as 00001111 is applied while the entry request is active, the system does not grant access, and both attendance mark and entry pass remain low. This confirms that unauthorized inputs are correctly rejected by the system. This shows that invalid RFID inputs are rejected, keeping all outputs low. In this waveform, we can observe the system response to multiple RFID inputs over time. When a valid RFID input such as 10101010 or 11001100 is applied with an active entry request, the system successfully generates high outputs for access granted, attendance mark, and entry pass. The entry pass signal remains high for a short duration due to the timer logic before returning to low. Meanwhile, invalid inputs like 00001111 and 00110011 result in no access, demonstrating correct system behavior and reliability. This shows that valid RFID inputs activate access, attendance, and entry pass, while invalid inputs are denied.